vulnerability management platform, Phoenix Security. He's a seasoned entrepreneur, author, and engaging host of the multi-award-winning Cybersecurity and Cloud podcast. He's currently leading the UK and I chapter of Cloud Security Alliance. He also oversaw HSBC's application cloud security and held a senior role at AWS. He's known for his visionary views. He's regularly invited as a keynote speaker at global conferences and outside work. He's a passionate marathon runner, snowboarder, and whiskey connoisseur. Please join me in welcoming Francesco.
All right, so now you know about me. I don't need the intro. We can stick in. Welcome, everyone. It is an absolute pleasure to be back here. I think with Richard, we were here 2019 before all the pandemic craziness started.
2020 also.
2020 as well, yeah. I've been here quite a while. As you can see, I love the sea, the sun, the people, so calm. And since that time, we did a lot of research about vulnerability data, and I have a lot of experience. I've been doing this and vulnerability analysis, vulnerability program. I've been in UK, as you have been in vulnerability management, and you have touched vulnerability, and you have spoke to developers. I have done it a lot, and I've been in the trenches, and I come here to actually maybe give you 2 or 3 ideas on how to approach that problem. And we made a company out of it, by the way. Sure. So I want to start to say, I'm coming from England, so Shakespeare, of course, is one of my authors that I love, and hence to fix or not to fix, that is the question. So I had to put it in there. Promise is not going to be a sonnet on vulnerability management, because that's going to be way too hard. Maybe ChatGPT could help on that, but maybe next time. I would say that in all my experience, in all my years, I never fix a vulnerability. You think I'm crazy? Who thinks I'm crazy? Hands up. 1, 2. Okay.
Well, we know you're crazy.
Thank you. So I focus on risk, because risk enabled me to communicate code with the rest of the community in the business, because fundamentally security is not a security problem, it's a business problem. We are here to help the business to make the right decisions. But if we talk about vulnerability day in and day out problems, and an enormous amount of it, we never get them to listen, because they only see us as a blocker, as a problem maker. And I started discussing about risk with the right people, with the right context. And that's the stuff that we're going to discuss today, about context and who to talk risk and who to talk vulnerability and what connect these two work together, because we need to talk risk to the business and vulnerability to the engineers, what to fix. If you talk vulnerability to the business, chances are it's going to go over their head very quickly. They're going to stop listening to you. But on the opposite side, if you talk about risk to an engineers, what am I going to do with that? So, if this works, doesn't, maybe I'm going to do it my own technology when it helps and when it doesn't. I'm going to apologize at the beginning. I use an insane amount of memes, because security is already heavy enough. So, let's laugh about it, and let's laugh about ourselves, because that's going to make it easier and cheerful. So, a little bit of me. Arola has done a wonderful job at introducing me, so thank you so much. I've been doing vulnerability management, cloud security, and application security for most of my life and most of my career on two sides of the fence. From a development, I have a development background, and I decided to move fences over and to help developer identify what's more important for them and run application security program at scale, get involved in the cloud, get involved a little bit with humanitarian and the UN in my past. So I've done my fair share of war zone and crazy places, but we're not here about that. We can talk about it after. And one thing that stuck with me forever is I had argument with development, I had argument with engineers, I had argument with business, but one common thing that killed all those arguments was data. You can argue with people, you can argue with opinion, but it's really hard to argue with data. I mean, if you're a data scientist, you might start challenging the data set that you looked at and the bias, but it's really hard to actually argue with data. So when I start looking at data-driven approach, I start seeing the beauty of fundamentally communicating with everybody with something that was logical, non-changeable, probably arguable, but was more direct and is not an opinion basis, data is facts, and it's really hard to argue. So I'm going to look at today to introduce you to fundamentally Appsec and look at Appsec as a whole, from cloud to code or code to cloud, depending on which marketing team you talk with. The dev view, the security view, and how we bring these to work together. And then the highlight of today will be all the research we've done around exploitability, stuff that we discussed with Brooks, and how to cut these data sets that we looked at. All of this research is fully open, fully available. Cut it, look at it, argue with it, because it's data. You can argue with data if you want. And then how to bring all of this home back to life with REST and a unified approach on REST. I hope you like data. So, as I mentioned, this is the world we live in. Vulnerability coming from up, down, left, and right. And the question I used to ask myself is, where do we start? Who do we talk to? Who does even own code or container or other stuff? Like, we've been hit left, up, down, left, right, and center by vulnerability. But most importantly, the knee-jerk reaction of security team is, okay, developer have this bunch of vulnerability, please fix them. But on the opposite side, I put back my developer hat on. That's not one of my priority. I know the business has a lip service of like, security is important, security is everybody's job. But what that actually mean to a developer, to an engineer? Nothing. It's not objective, it's not sprint, it's not amount of stories that you need to dedicate. And on the opposite side, as a security team, are we helping them getting their backlog, getting the story right, getting the thing that they need to do and deliver in that particular sprint done? No. Right now, we're talking two different languages. And again, I'm going to reiterate this over and over and over. Security and vulnerability are a product and business problem, are not a security problem. We're here to raise it. And as a security team, we have another challenge. Sorry for the color, they seem to be a little bit washed out. But the concept fundamentally is the few of us who argue or agree or disagree with those numbers that we have one security professional for 250 developer or 50 developer. Who's been there? What number do you guys think? Is it right? Is it wrong? It is more? It is less? The ratio?
It's us minds. It's us market to Balkan, bro.
Sorry? Well, no. In an organization, traditionally you pair a security professional to how many devs? 50, 100? Okay, let's go a security professional. Anybody that can talk to an engineer that has the ability to communicate with a developer and make sense out of it and basically give value, not just throw a bunch of big word and stuff like application security people matching to developer. It can be even more. It can be up to 750 if you trust Ponemon Institutes on that data. It can be 500 if you trust GitHub, 550 precisely. So 250 is actually a conservative number in that element. And since COVID, I think a lot of organizations have decided, cool, we need to go global digital tomorrow. So what happened is throw all the stuff that we used to develop on premises in the cloud And hence our attack surface has increased up to 300% if you trust Ghana on their recent study on vulnerability data. So in all this stuff, we have 4 actors that operate: security, business, development, and operation. Dev and ops kind of collaborate right now together, but the challenge is security and development don't. And we don't have a common language that translates an objective from anybody in the business that is risk into action for engineers. Yes, we can say we shall fix all the critical. A critical vulnerability for a team might be 400, for another team might be 5. They're not equal. Okay, let's use SLA, service level agreement. We shall fix critical vulnerability in 4 days. Okay, I have a sprint release of 6 months. How am I going to meet that? So those numbers are great to actually put a line in the sand, but they don't adapt to how engineering works. So we end up in a situation that, okay, I'm a security person, I run a security scan or run a pen test report, I give it to a development team and I say, can you please fix all of this inside this X amount of time? And then you start the begging game. Please, 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 at least look at the critical. Please, of this critical, can we look at these 5 things? Was it been there? Was it done that begging job? I have. Raise of hands? Come on, be honest. Everybody has. And the thing is, they're not incentivized to look at this stuff. They're not incentivized to look at vulnerability until we make it in their terms and their priority. But as a security professional, it's not our objective. It's a business perspective. It's a business job to say, okay, in every sprint we dedicate 2 story points, 5 story points, 6 story points, X amount of vulnerability. Those are numbers that, first of all, make sense to an engineering team. And second, it makes sense. Now, I've been on a hike here in the valley, and I've included this at the last minute photo. I ran out of water halfway through. And then this, after 2 hours walk in 35 degrees, was the best water I ever had. And this made me think a little bit, and sorry for the cringe LinkedIn sentence, but this made me think this is a really good LinkedIn post about security. Of if we're drowning or if we are on a shortage of direction, having that water, having that direction, having a number that we can relate to is super important. And it becomes even more important when somebody gives us a direction. So when we can go from SLA, fix a number of criticals, fix a number of problems, into this is the stuff that you need to look next week. And don't get me wrong, triage, manual triage is hard, is humbling, is brutal, because as a security professional, we need to look at a lot of tools nowadays. SAS, Dust, SCA, Rust, if you played with it, CSVM, infrastructure scanning tool, cloud tool. Am I missing something? Mast, IAS, Web Dust? Anything else I'm missing from the card game of security? And correlating all of this information is hard, and we expect that engineers just look at all this and say, well, make sense of it and fix the critical from all these systems all in one go. Or according to SLA, that some organizations say, yeah, critical 5 days from all of them. Good luck with that. Now, SDLC and Appsec is hard, and most of the business don't absolutely understand the complexity. You have criticality, just go and fix it, right? Simple. Well, it's not that simple. I like to look at an SDLC pipeline in 3 blocks supported by 2 lines. So security design, build and test, and ops. And then support by risk management, governance, cultural change, and education. This is how I like to look at it. But if we break it up, fundamentally at every stage, we have scanning capabilities. And I like to look at where code gets produced before it gets operational and when it gets operational. identifying and fixing vulnerability in the left side of things can be fast and quicker if you look at the problem atomically. You have something that comes out in your IDE while you write codes, quickly identify, can I fix it, can I don't fix it? If you can't fix it, put it in a backlog, ignore it. But the chances are, at that stage, you'll be more likely to fix it there and there. Now, a lot of the vulnerability pops up at a later stage. It's theory. Or they're too complex to fix there and then. So we need something that look at all that backlog of vulnerability, translate it into risk, and enable the engineers to actually go through it and say, I'm going to ignore this, I'm going to focus on this and stuff like that. So that's how I call it fast triage. Identify the problem there and there, fix it or not, or demand it to a more complex backlog. And this is all the vulnerability management language. And if you've been at the conference or any other security conference, you heard probably the term stop the bleed. What's heard the term stop the bleed for vulnerabilities? No? 1, Dustin, 2, 3, 4, all right. So stop the bleed is basically block the critical vulnerability, block X amount of vulnerability as soon as they get produced. It's great because we force engineers to actually think in certain ways, but can also cause friction. What if the library doesn't have an upgrade? What if I can't touch the library? What if that particular piece of code is actually a false positive and I need to raise an exception? Taking this with a pinch of salt is probably the best scenario. Putting one-off solution doesn't solve the problem. So security gate can help in some stage, but most of the time cause resentment. A more complex security gate might help in that, but we can touch it later. And then what happened with the backlog of your vulnerability? Like from a stop the bleed perspective, maybe you're not going to touch that code at all. So how a security gate is going to help you there? And what happened with exception, as I mentioned? All right, I'm going to speed it up a little bit. So on the manual triage stuff, these are the reasons why it doesn't work and it doesn't scale. If you're a small organization, 1,000 employees, 100 devs, probably 2 or 3 security professionals, you can spend 48 minutes per team. Roughly, to understand a complex vulnerability could take you up to 9 hours. 48 minutes, probably not the best time. But then if you take it at scale, a large organization, if you see the security team doesn't always scale at the same time. So matching one security person to 200 security team and shrinking the vulnerability analysis to 10 minutes when it takes 9 hours, what is the quality of that work? So we need to reduce the number of vulnerability overall, and you're going to hear this number over and over and over, but today we're actually going to look at the data behind this number that is maybe for me a little bit more exciting than just look at statistics that are empty. And we discussed this morning with Brooks, I'm obsessed by data, so we're going to see the data that sits in behind, and at the end of the presentation, I'll give you the link to actually go and play with that data. The common one is 10% of vulnerability are actually exploitable. Of all the stuff that a scanner can find, 10% of that actually have an exploit. Now, it depends by the scanner. A security scanner from a code perspective might have some other caveats, but in general, 10% of this stuff is actually exploitable at scale. Now, 5% of those vulns are actually reachable. Might be a system buried down in your stack, might be a system that is actually, or a library that is actually called in a specific piece of code. And 1% of those are actually targeted by attacker right now. That's the body of threat intelligence that come into the place. Now, in terms of data, and just to give you some numbers, this is a sample set out of a Gartner report looking at 20,000 vulnerability, of which 1,000, yes.
On the previous slide, but yeah, and going to 5, are you saying help or you're saying
of the total number? Of the total.
enough of that?
Yeah. So less and less and less. Thank you for the question. Data is important, but also context is very important. No. It's in total. Although all the vulnerability you might have, 10% are actually exploitable, and then you narrow it down and narrow it down and narrow it down. Because triaging is fundamentally creating that funnel into what I'm actually need to look at, and then what, as a team, I'm tasked to look at. And based on that data, you can see the drastic reduction of vulnerability that are actually exploitable. Now, even if we look at the 1,500 and we say, yeah, let's fix it with SLA, we have proof that, first of all, attackers are looking or attacking vulnerability much faster. 180 days are roughly on an average how much we are taking to fix vulnerability. On a critical, 3 days to exploit a critical. Take it with a pinch of salt. This is a data-driven approach based on a selected number of vendors and organization. But it tells you SLA in itself are not a way to go. And they done an analysis on how many part of the business that they interviewed are actually hitting SLA. None, 0%. SLA are completely crap. Sorry for my French. Now, what we've done is, okay, out of all these percentage bases, what is the data that sits behind? So we run scripts to basically scrape the entirety of GitHub, the entirety of meta-exploits, the entirety of HackerOne, bug bounty program, and so on, and then start crossing this data set together. EPSS as well. Who has heard of EPSS here in the room? Great. EPSS is exploit prediction scoring, is free and open source threat intelligence that can help you seeping through a lot of this vulnerability at scale. Now, if you look at the data sets, there are some patterns of organization that repeat with each other. So top 10 vulnerability by popularity. Popularity is the number of links that we found in GitHub, ExploitDB, and actually exploited at scale. So ExploitDB verified. Microsoft, of course, has the biggest attack surface. Oracle, Debian, and Apache are the very popular one. Now, all of these get kind of confirmed with who is attacking things at scale by EPSS. This is a really good indicator. These two are good indicator of, okay, there are links out there. With EPSS, let's look at the links that are actually exploited at scale. Now, if you look at criticality, so how important are those vulnerabilities, you might find that some of them are there in terms of vendors and vulnerability, but most of the time is a misleading element. So creating SLA by criticality gets you wrong a lot of the time because helps you focus on a problem that has been tested atomically. That's how criticality is determined. Not change that much, not change that frequently. NVD doesn't have the resource to even assess the vulnerability. And right now they're getting hit by vulnerability generated automatically. So the time they can actually spend on evaluating a vulnerability is fractional. Now, the other indicators are actually based on real data set and real data. Now, I'm going to just demystify a little bit those terms because everybody throws those terms around. Like, what is exploitability? What is the definition of exploitability in your opinion? Who want to try that approach? How do you determine if something is exploitable? And what does that term even mean? Nobody's going to try. Yes.
That the vulnerable code would pack through the rod to not deploy.
Okay. And that makes it something exploitable, but is likely to be exploited? Or is somebody looking at it?
Depends if there are tools available for it. Is there a plugin, any tool? Do you have to chain it with something else to get to it?
And that's perfect. Thank you very much for the definition because that's perfect. That describes exploitability as a complex. Yes.
And also, whether it's just a researcher discovered this vulnerability or whether it's exploitable or what.
Correct. So if it's a proof of concept that somebody has written and deployed it out there, if it's a piece of code that can be actually run in a Metasploit or an exploitDB or a Kali Linux that can be taken, scripted, automated, if it's a remote code execution and things like that. Exploitability is formed by several factors. So I'd like, and this is my opinion, this is not facts, as we said originally, so take it, but I like to break it down into popularity. So how popular are a particular set of exploits, and this is what we cut the data with. Number of links in GitHub, number of reference in package store, prices in bug bounty program, and how many actors are looking at that. There is a small percentage of those vulnerabilities that get discovered and they don't transition yet in MVD. Usually the time is a couple of weeks, and 0 day from Trend Micro and Google 0 Day Project are a good couple of reference of these things while they get discovered before they made their entry in the National Vulnerability Database. Another aspect of exploitability is this a proof of concept? Is this particular vulnerability exploitable remotely? And that's the RC or remote code execution element in a vector or in the description of the vulnerability. It is actually exploitable, and it's the data that you find on the exploitability at scale actually reliable. And that is where it takes basically the active exploits. So do we have evidence of people actually attacking it at scale? It is used, it is confirmed, or is it just being reported? Yes.
How about it would maybe this form that it shows really complex squat?
It is.
So I think the more, I guess, systematic way of going evaluate is to estimate, because you can know the trick calculate it, you can estimate what's the probability that this will use, and then go to risk.
And that is perfectly why I love risk, because if we have criticality is just a number. It doesn't give us the context. It doesn't give us the probability. And as we can see here, just one of the factors that is inside the criticality aspect is so complex and is so variable, and it changes based on a lot of elements, like where is that system running? Is it somebody looking at it? And those things can change. Like if we take Log4j was discovered, I think, 2019 as a problem. It never got weaponized and attacked at scale up until last year or last couple of years. So the profile of a vulnerability was already there, changed because all of a sudden there was an active exploit that was RCable. Sorry if I'm making up terms, but I'm a security guy. I like to make up terms. So something that got actively exploited, there was threat intelligence confirming the active exploit, people that were looking at it, and it was remote code executable. And there is actually even more complex element of how much of this we actually trust. So there is another aspect of exploitability, it's called confidence. How much we trust this data set. There are certain data set, okay, we have an exploit in GitHub. So what? Do we have confirmation that that exploit is actually used at scale, used by somebody, and trustworthy? Sometimes it can be just garbage. So by changing up popularity is a good element, and all these data sets like GitHub give us good reference of information that are available out there. There is an exploit available out there. But bug bounty means that people are actually reporting these things at scale. HackerOne, Backroute, we have statistics available out there. 0 day means that researchers have actually looked at them and reported. So that is actually high confidence level. EVSS is good. So high EVSS, and I'm going to touch on what high EVSS means, is good confidence that people are looking at scale. It kind of hit and miss on some occasion, but we can talk about it later. And then we have researchers like CISO or paid CTI that are actually people that are looking at exploit at scale, looking at threat actor and giving you that precise information of, yes, there is somebody that is looking at it, is confirmed. So that is where I classify for high confidence. And then low confidence is where is this data coming from? NBD can be full with garbage most of the time because a lot of those reports are automatable. And we saw things like even demo projects like security codes or down vulnerable application making their way inside NBD. It was caught very quickly, but that is a sign that an automated report to a system doesn't fill me up with confidence. And unfortunately, we have all this data set to make a decision on vulnerability. Now, if we look at data sets, I'm going to ask a quick question if somebody remember who was the top popular vulnerability that we saw in the first slide. Okay. Not yet. Microsoft and Oracle are the one that, yes. Google NetApp, like Google for Android phones and stuff like that, are the ones that are actually more probable in this data set. So there are more links available out there. Now, what do you think why those systems or those particular vendors are out there more exploited at scale? Why do we have so many things for Microsoft and maybe not so many things for Cisco? Let's put it this way. Yes?
More individual.
Yes. They have old products, so their attack surface is enormous, and they have a lot of old products that are still out there that are out of support, out of patch. So the bigger the organization is, the more product line it is, so the harder it is to keep everything updated, even on the running one. And then we have a lot of systems that are actually not upgradable. Now, CISO CISO data, and CISO is the non-exploited vulnerability database. You can cut the data as well with cross-reference data sets. So we cross-reference CISO with the popularity. So what is the vendor with more popular in CISO? It cannot confirm and didn't confirm the data. So Microsoft is still out there. But Apache and Log4j, of course, was the one that got confirmed, kind of. It's a more popularity element. Now, if we look at another data set, top routinely exploited vulnerability is another research that CISA published every year with the very likely one. And you can cross-reference that data set with EPSS. So more or less, you have the same kind of information of the likelihood of exploitation at scale. This is automated. The other one is manually, is a collaboration from UK government, Australian government, New Zealand government, and the US government on actually looking at what's more exploitable based on CDI. That's a really high confidence element. This is very good confidence element that you can use to cut your vulnerability down. Now, if we look at OWASP as well, who knows OWASP top 10? Who knows the data that sits behind OWASP top 10? How OWASP top 10 is being calculated? Variable has something to do with it. We have a lot of data set coming from Variable, but EdgeScan and others and us are providing a lot of these data set. So if you see OWASP top 10 has changed a lot over the years because the type of vulnerability and also the definition that unfortunately we give to this vulnerability changed over the years. So we're given a couple of reference, and if you want to play with data and data visualization, we see how some of the vulnerability appear and disappeared. But there are certain ones, and this number here is actually how the top 10 are actually calculated and how they map to the CWE. Because unfortunately, as security professional, we like to complicate our lives. So we have OWASP top 10, CAPEC, MITAP, CWE, CVE. We have a lot of all of these, and unfortunately, they're all disconnected. Unfortunately, I am going slower than what I was supposed to, but there are some commonality in terms of type of vulnerability that you can also find, and how do you take this data set and you apply to application security. So cross-site scripting is still very, very popular in terms of vulnerability, exposure of sensitive data, of course, and remote code execution. Those are logical elements, but when you look at a specific data set and you can mention those facts to a developer and where they can actually focus, this is data-driven. This is what people are looking at and attacking. So if you're doing your security champion programs and you're talking to a bunch of developers, you say, well, where should we start and focus? Maybe we have a lot of these CWE at scale. Maybe we start there because people are looking at it. So you can use this data set to actually corroborate a lot of your statements, and they make almost bulletproof. Happy to be challenged on that. One other data set that I was really pleased to see CWE to start creating was they create CWE top 25, and we created cards out there to review, and all these diagrams are actually there in cards. But one of the things they started doing is, what are the persistent issue that you have over the years? So we start seeing basically trends over the year. I'm gonna skip through some of this stuff, but one of the things that I wanna leave you with is risk. A lot of these elements can be changed and can be automated with risk. So exploitability as a terms can be put in there, and a lot of these data sets can be automated. Severity, criticality, all of these things forms a much better way to talk with your business, because they can understand the risk, it communicates that sense of probability and likelihood of exploitation. And they can be translated to engineers, because we know that risk can be translated in a number of actions to reduce basically that risk. And that's how we close the loop between risk and specific amount of action that engineers need to do, then create that common language in different contexts for the various teams. I'm going to leave you with basically the way to chain up and automate a lot of these data sets. There is more complex behind this, but this is what we do as a company, and to make your life easier and to translate basically risk level to vulnerability. So we take the hard job so that you can take the easier job of talking to developer. That's an easy job. So thank you very much for coming. I'm going to be available out there for questions. And I think we ran out of time, so unfortunately I need to leave you, and I'm going to be available out there for questions. There is some swag out there, so please feel free to take swag, to take data set and data visualization. It's been an absolute honor to be with you today. Thank you very much, SoCal.
Well, that's fun.